Wondered how top companies track global competitor pricing changes on the Google Play Store automatically? Today, you will build an n8n in Python workflow that scrapes dynamic pricing data across different regions, keeping your market intelligence completely up to date. Welcome! In this hands-on screencast, we are combining the visual orchestration power of n8n with the precise data parsing capabilities of Python. Mobile app pricing is heavily localized, meaning competitors change prices based on user geography and regional purchasing power. Manually tracking these fluctuations is impossible at scale. By the end of this session, you'll have a robust, automated pipeline that triggers on a schedule, passes target app identifiers and country codes to a Python script, extracts the dynamic pricing structures, and stores them neatly for your pricing strategy team. Before writing code, let's understand how our hybrid architecture works. n8n acts as the conductor, managing schedules, webhooks, and data flow between different APIs or storage layers. When triggered, n8n passes payload variables like package IDs and country codes into an execute command node running a standalone Python script. Python handles the heavy lifting of HTTP requests with custom headers, parsing HTML responses, and handling fallback logic if anti-bot measures trigger. This separation of concerns keeps your infrastructure scalable, easy to debug, and simple to deploy on any server. Let us start by writing our foundational Python script. Because n8n will pass configuration parameters into our script via command line arguments or environment variables, our script needs to handle these gracefully. Here, we set up a mock environment using standard Python libraries to simulate receiving target app packages and regional country codes, ensuring our script is fully testable locally before connecting it to n8n. When scraping global app stores, your requests must mimic users from specific geographical locations. Google Play serves different prices and availability depending on the client's locale and IP context. We achieve this by crafting specific HTTP headers, including accept language and regional proxy endpoints if available. Our Python script needs to build these request headers dynamically based on the inputs provided by n8n, ensuring that when we query the store, we receive the exact localized pricing HTML or JSON payload. Now let's write the code that constructs our HTTP request using Python's built-in erlib library. We do not need any third-party dependencies like requests. The standard library has everything required to build requests with custom headers and user agents. This snippet demonstrates how we format the target URL for the Google Play Store and attach regional headers to fetch the raw storefront data safely. App Store pages are heavily dynamic and often rendered via client-side scripts, but core pricing data is usually embedded within structured JSON LD script tags or meta tags for SEO purposes. Instead of heavy third-party parsers like Beautiful Soup, we can use Python's built-in regular expression module to extract specific price strings and currency symbols directly from the raw HTML payload. This approach is lightweight, extremely fast, and less prone to breaking when parsing minor DOM updates. Here is how we implement robust string matching to extract pricing information from the fetched HTML. We use Python's re module to look for common price patterns, such as currency symbols followed by numeric values. By designing fallback patterns, we ensure that even if the store layout shifts slightly across different regional deployments, our script can successfully isolate the correct pricing data. Once Python extracts the pricing data, it needs to hand that data back to n8n in a clean, structured format. The universal standard for this inter-process communication is JSON. By printing a valid JSON object to standard output at the end of our script, n8n's execute command node automatically captures it, parses it, and transforms it into individual workflow items. This enables downstream nodes to branch logic based on price thresholds or store the results in a database like PostgreSQL or Google Sheets. Let's combine everything into our final, complete Python script. This script accepts arguments, fetches the localized store page, extracts the pricing using regular expressions, handles errors gracefully, and outputs a clean JSON payload ready for n8n consumption. Notice how everything is self-contained with standard libraries, making it completely plug-and-play in any Docker container or local environment running n8n. The script failed because com.example.app is just a placeholder name used in the tutorial, not an actual app on the Google Play Store. When Python tries to request that URL, Google returns a 404 error because the app page doesn't exist. To test the code properly, you need to replace it with a real app's package ID. Here's the corrected version, let's type it in and run it again. With your Python script fully tested, deploying it inside n8n takes just 3 simple nodes. First, use a schedule trigger node to run your workflow daily or weekly. Second, connect an execute command node that calls your Python script, passing dynamic parameters using n8n expression syntax. Third, route the JSON output from Stout into a Slack notification node or a database writer. You now possess a fully automated global pricing intelligence system that operates 24/7 without manual intervention. Congratulations! You have successfully built a global competitor pricing scraper using n8n and Python. You learned how to craft regional requests, parse dynamic content with standard libraries, and output clean JSON data for workflow automation. Feel free to extend this project by adding multi-currency conversion APIs or setting up automated Slack alerts whenever a competitor drops their subscription price. Happy automating, and see you in the next lesson.